Welcome everyone. My name is Amit Chakravarti. I am the marketing manager for Siemon in IMA region. I hope you can see the screen and hear my voice clearly. If you are facing any difficulty, I urge you to log out and rejoin the webinar. We will wait for 1 or 2 minutes more so that some more people can join in before we start the presentation. So kindly sit back. We'll start the webinar in exactly 2 minutes from now. Bob, you have the control?
I do.
Okay, we'll start in 2 minutes.
Great. Syed, you ready for me to start?
Yes, I'll just
Go.
yes, 1 minute. Yeah. Warm welcome to all the attendees. I take this opportunity to thank every one of you for showing your interest in this webinar. The topic of today's webinar is how to make a smart building truly intelligent. The presenter for today's webinar is Mr. Bob Allen, who is our Global Solution Specialist for Intelligent Building Solutions. Bob has over 15 years of experience in the IT industry and previously worked at Honeywell Building Solutions, helping customers optimize and integrate their buildings. Recently, Bob was appointed as the Vice Chair of Continental Automated Building Association's Intelligent Building Council and holds an MBA from the University of Hartford. We are also pleased to have Mr. Prem Rodriguez, who is the Director for Sales and Marketing for Siemon in the IMA region. Before starting the presentation, I request you all to keep yourself in mute. At the end of the presentation, there will be a Q&A session. You can type in your question in the Q&A section of the webinar tool. We also have a free application guide for you, which can be downloaded from the handout section. You will also get the recorded version of this webinar. So without any further delay, I now request Bob to please start his presentation. Bob, over to you.
Thank you so much. And I am excited and honored to be able to speak to you all this morning. Today's presentation is how to make a building truly intelligent. And I've been with the Siemon company for a little over 9 years. This is the most challenging presentation I've ever done, teaching you how to make a truly intelligent building in 20 minutes. So we're going to have some fun today, and we're going to give it a try. I can share with you a lot of experience, and I can share with you a lot of changes in the industry. And some of the biggest changes that I have seen in the last 10 or 12 years that I've been with intelligent buildings. One is the financial model, that we can actually build smart buildings for less money than we can traditional buildings. And the other is the technology. We're going to talk a little bit about both. With the technology in intelligent buildings, the big difference between what we have today and what we had 10 years ago, 15 years ago, is that all of the systems in the building have now collapsed onto the network. This goes all the way back to the late 90s when our phones became voice over IP. And then from there, our cameras and our HVAC. And now, about 10 years ago, lighting has become networked lighting or PoE lighting. Sometimes we call it digital lighting or low voltage lighting. This is a very big change in our buildings. The biggest change that I've seen since HVAC went from pneumatic or an air-driven system to DDC, a digitally controlled system. And it's really doing the same thing. Lighting has forever been a very analog circuit-based system, and now we're able to digitize it. And the reason that that is so important is because lighting is the most dense application in the building. And if you can now imagine every one of those light fixtures with a built-in sensor or a sensor associated with it, we've created this digital platform throughout the building. And this platform has the ability to collect vast amounts of data in the building. And that data can now be shared with other systems. It also allows us the ability to design a complete IP building from the bottom to the top. And because of this, we're able to digitize the building environment. And it changes the way we think of our buildings. If I asked you, what is a building? Most of you would tell me it's bricks and mortar and glass and carpet, all of the physical pieces that go into a building. Well, the change we need to make in our mind is we now need to start thinking of buildings as an operating system. I call it BAOS, building as an operating system. Because when we think in that type of an environment, we can now, our buildings can be more flexible, they can be more dynamic and have the ability to change with the needs of our building space. The best way to think of how we design our intelligent buildings is your smartphone. When I go back in time to 2007 and Apple released the first smartphone, it was amazing. A touch screen, color, all of these wonderful things in a phone. But the real genius behind the smartphone was iOS, the operating system. The reason our cell phone is so attached to our life is because of the operating system. When you need your phone to do something, you can go to the App Store and download an application, and it works. A great example, I was talking to the team before the call, and I was mentioning to them that it is 28 degrees Fahrenheit here in the US. I'm in Connecticut in the US, about halfway between New York and Boston. But that doesn't mean a lot to my friends in the Middle East because you use Celsius. And my phone has a conversion app. So I was able to tell him it's -4 degrees here in the US, and he shared that it's +40 or about 106 degrees Fahrenheit in the Middle East. So quite a difference, but that's just one of the useful tools that I wanted to have on my phone to make my life easier. Well, as we're seeing companies bringing people back into the office space, they're looking for applications in their buildings. They're looking for their buildings to adjust to post-pandemic life. That we need things like social distancing applications. And in our legacy buildings, our traditional buildings, in order to do that, we need to run new cables, provide some new sensors, add new servers, add new software. But if we had built our building as an operating system, all of that data exists on the original existing servers. We're now just putting a new app on the server to manipulate existing data to give us the desired social distancing output. I don't know what the next pandemic is going to be, but I do know our buildings will have to adjust to it. Some of the top benefits of a BEOS environment is elimination of proprietary software, and I'll talk more about that in a minute. Making sure you can leverage the open market during the operations phase makes your facility management easier, lowers your cost to operate. Making sure the edge devices can be plug and play, and not from a security perspective, but making sure we have power, connectivity, and control at the edge. We talked about this. Apps can be installed like they are on your smartphone. Improved life safety, along with automated triggers and events, and even lower energy consumption. I mean, it's very well documented. Intelligent buildings are 40 to 50% more energy efficient than traditional buildings. And all of this, of course, lowers your overall operating costs. And lastly, sustainability. And when we think of sustainability, we usually think of it with energy. A sustainable building has solar and wind and all of these kind of net zero type applications. Well, when I think of a sustainable building, I think of all that, but I also think of the infrastructure, how to make sure that the infrastructure that we put into place, the cable, the servers, the switches, all of these components, the sensors and so on, are going to last 20, 30 years so that they can support all of these future applications. We want the building to be able to adjust and to our needs without having major cost. Oops. The building you see to the left is our traditional or legacy type building. Each of those systems is on their own network, which could be a different media type, speaking their own languages. And worst is they come down into those boxes. And those represent proprietary vendor locked software. Very expensive to build that way. You can do some degrees of integration, but it's very expensive and you're subject to translation devices and many different other type of technologies to try to get these systems to communicate together. What we want to see is that building to the right. And that's where all the systems are on a single unified IP infrastructure, having a single contractor deployment model. That saves a lot of money. We can eliminate up to a dozen subcontractors on the in a project, which lowers your costs tremendously. And we want to see that box down the bottom. That represents an integration platform. And integration platforms have been around for many years, but the problem with the existing platforms is not the integration platform, but our procurement or our purchasing process. We typically specify that integration platform at about the same time we specify all of the edge devices. And the result of that is we end up with a very robust software that's only doing HVAC. Well, what we want to do is we want to bring that partner, we call them MSI, Master Systems Integrator. Bring them into the design team very early. They can work with your existing design team to not take their place. So for example, they would work with your MEP company, and they're not going to help calculate airflow and duct size and all these things. What they're going to do is they're going to say, you need to have a controller here. This is the specification the controller needs to follow. They're going to help with communication protocols, connectivity standards, power standards, so that when the other systems like card access, cameras, even life safety, HVAC, when all of those specifications go out for bid, it doesn't matter what vendor you use, what manufacturer, as long as that edge device complies with the specification that the MSI helped you write, you do not need their proprietary software. Those edge devices should plug right into the integration platform and be able to work seamlessly. And what that means during the operations phase is if that card reader fails somewhere down the line, 5 or 10 years in, you don't need to go back to the same manufacturer. You can, but if there's a better product at a lower cost on the market, you can use that as long as it complies with the specification. This is a great example. This project is in Erie, Pennsylvania, and it's a small building, about 1,800 square meters. But I met with the CEO and the CEO's architect, and they wanted to have the most intelligent building in Erie, Pennsylvania. The problem was they were over budget. And truthfully, when I met them, they really did not have it designed as an intelligent building. So I brought one of my master systems integrators into the meeting with the CEO and the architect. And the architect identified those systems you see to the left, and the architect told us that the cost to purchase and install those systems is $970,000. Well, with the help of the MSI and rewriting some of the specifications, we were able to do those same systems for only $480,000. We eliminated proprietary software. We used power over Ethernet wherever possible, including power over Ethernet lighting, and we lowered their cost to build those systems by 49%. We're seeing projects here in the United States where we are saving over $2 million per 9,500 square meters of new construction. There are also tremendous savings on the maintenance side of the building, the operations side, and we call it FM, facility maintenance. And forever, we have been doing our FM based on the calendar. Every 12 months, we need to change our filters. We don't even know if those filters need to be changed. We've just always done it every 12 months. I go get a physical every year because that's what my doctor says. I go to the dentist twice a year because that's what they tell me. I think I brush my teeth very well. I probably don't need to go every 6 months, but that's what they tell me to do. Well, now in our buildings, we can start doing this maintenance because we need to do it, not because the calendar tells us to do it. For example, an air handler with an analytic platform like FDD, we call it, fault detection and diagnostic, and that is part of the integration platform. We understand the baseline energy consumption of an air handler. And we know that as a filter gets dirty, there's a steady increase or sloped increase in the amount of energy that machine is going to use. The more dirty a filter is, the more energy it takes to push air through and maintain our differential pressures. We also know that if we replace the filter, energy goes back down to the baseline and we can calculate that savings. We can then compare that savings to the cost of replacing the filter and develop an ROI, return on investment. If that ROI is not for 2 or 3 years, well, the filter is very clean. We don't need to waste our time and our resources changing it. But if that ROI is only a couple of months, well, then that's a very dirty filter. We do need to spend our resources replacing it. Here's a lot of things you could be doing with PoE that you may not be now. And the reason we want to be doing this is because here in the US anyway, the average cost to bring AC power to the edge is about $1,000. We have a breaker, a panel, a transformer, a conduit, all these different things. We could bring PoE to the same location for only $250. And one of the things I want to talk about are the battery chargers for phones. We can get power to the edge less expensively with PoE. So we should be putting in PoE powered USB charging plates at all of our cubicles, reception areas, conference rooms, anywhere in a building, anywhere that people are going to charge their device. Because if you don't, what do? You're going to put that iPhone brick in the wall, and then you're going to put your USB into that. And all that brick is doing is converting energy from AC to DC and doing a terrible job. We lose 30% of our energy at the device when we convert it at the device level. Network switches convert energy at 95% efficiency. So just changing where we convert energy from the device to the network, we can save 25% of our energy. Thinking like that with lighting, your new buildings are going to have LED lights. They will either be AC or PoE LED lights. And if you use an AC LED lighting system, you are bringing AC power to a driver on the top side of the light fixture. It's converting energy from AC to DC and powering the exact same circuit board that we have in our PoE light systems. The problem is that driver loses 30% of its energy, goes up into the ceiling as heat, which now needs to be conditioned before coming back down into the occupied space. In addition to that, that AC to DC driver accounts for 54% of LED light fixture failures. So when we look at a PoE lighting system, we eliminate a failure point, we pick up 25% energy savings just in converting the energy at the network level rather than the light fixture level, and we remove a 15% heat load in the ceiling space. This project is from Fort Worth, Texas, and they did PoE for everything they could, and then they used direct digital or DC power for everything over 60 watts. The result was saving almost $500,000 on the cost of their infrastructure, which was about 25% of that budget. In addition, lowered their energy costs by about $100,000. So here's a list of some of the things that you could be doing with PoE. If you use PoE for everything I'm aware of in a building, you'd add about 208 low voltage drops for every 950 square meters of new construction. But keep in mind, every time you do that, you're eliminating an AC drop, and in most cases, an AC drop and a communication cable. That'll give you about $156,000 in capital cost savings, or $1.56 million per 9,500 square meters. And I didn't say this earlier, but by using the integration platform and eliminating proprietary software, you can lower your cost to build by $500,000 per 9,500 square meters of new construction. So putting those together, that's where you see savings over $2 million for every 9,500 square meters of new construction. This is one of my favorite case studies from Pasadena, California, and they went with PoE for everything they could in the building. As a result, over 55,000 watts of PoE lighting, over 8,000 total connected IP devices, over 2,500 of them were PoE light fixtures. But the most impressive part of this building, it was a very high-end biotech space. The most impressive part was we worked with over 20 different custom lighting manufacturers. And why do I tell you that? Because we can do PoE lighting in the Middle East, in Africa, in Asia, in Europe, anywhere in the world with a local fixture manufacturer. So they can make light fixtures in your country, and we can still enable them with PoE. So you have all the sensors, the functionality, and the energy savings and performance of a networked lighting solution. We can even save you money by doing this. This shows that in New York City, the most expensive market in the world with the most difficult unions in the world, we were able to do a PoE lighting solution for 18% less expensive than a traditional AC lighting system. We saved 18%. And the last case study I have for you is Water Park Place in Toronto, Canada. And I like this one because it was a tenant space. They didn't own the whole building. Cisco has about 9,500 square meters in the building. And as a tenant, they were able to converge their HVAC metering, lighting, CCTV, and access control all onto one network, one integration platform. And the result was they lowered their cost to build by over 10%, and they lowered their energy consumption by over $600,000, mostly offset by that PoE or digital lighting solution in the building. Now, I was told by Amit when I first agreed to do this presentation that I only had 20 minutes, and I think I hit 20 minutes right to the number. How did I do?
Great, Bob. Thank you so much.
And now everyone knows how to build a truly intelligent building. That was amazing.
So before we start our Q&A session, I just wanted to let you know, audience, that if you have any queries, please write to us at info_me@siemon.com. If you have any questions, please type in that question in the question panel, and we'll now take your question. So Bob, here is the first question. Security is always a concern. How do you make sure that the company is safe with so much IoT exposure?
That is a great question, and you're absolutely right. Security is one of the biggest concerns in intelligent buildings. I'm going to tell you a couple of things on that. One, intelligent buildings are more secure than your existing buildings. Older legacy type buildings do not have the same security policies and procedures that we have in place today. And I'll give you a great example. I used to work for Honeywell before coming here. And I could go to some of my very high-end financial customers, walk into their facilities room, and turn the keyboard upside down in front of their building automation system, and there was the username and password so that I could hack into their building automation system. And the reason that's so important was because fast forward to about 5 years ago when Target, the big retail company, had that big breach where millions of people's social security numbers and credit was all stolen for the black market. That was through a legacy building automation system. So now that we have the opportunity to do this with IoT, we can apply our most stringent security and safety procedures and policies to the systems. And there are multiple ways of doing this. You can have your OT, operational technology. That's what we call the intelligent building networks for systems. You can have your OT on the LAN. There's no problem there. I think that's the way to go because that is your most secure platform in your building. Or you can have it completely separated. And keep in mind that, we said plug and play to the edge. That doesn't mean that I can walk over to the edge and plug in my computer or plug in an edge device and I'm going to have network access. All it means is connectivity is there. There are still the ports need to be turned on, or the other firewalls or what have you, security procedures in the background that are going to keep someone from being able to get onto your network even though they're in the building. But at the end of the day, it needs to be properly planned out. And we even have partners in our ecosystem that specialize in intelligent building security to help navigate that part of the building and the process.
Okay. So Bob, next question is shielded cable required for intelligent building?
Uh, so is it required? No. Is it recommended? Highly, highly recommended. And that's because, again, sustainable. You want to put in an infrastructure that's going to last throughout the applications. And as new applications hit the market, there are two things that need to be considered. One, bandwidth. Future applications are going to require more bandwidth than current applications. So if you use a low-grade infrastructure, you will not have the ability to take advantage of new technology. It's a lot easier to replace an edge device and a switch port than it is to replace that cable infrastructure in the middle. The other, and this I think is an even more important consideration, is power. You might have a device today that only needs 30 watts of power. 5 years from now, that might be a 60 or 100 watt device. Or you might be going to a node that can take that full 100 watts and be able to distribute it to multiple devices at the edge. If you do not have the right infrastructure in day one to deliver 100 watts to the edge, then you now need to recable your building to take advantage of that technology. So highly recommend a shielded 6A solution.
Okay. Yes, there is a question whether the recording will be shared. Yes, the recording will be shared. You will get a mail from GoToWebinar where the recording will be there. There is a question which says, how Siemon help in lighting and LED for enterprise? Bob, you want to take this one?
Can you say how can Siemon help with lighting in a building? Is that
Yes,
was
lighting and LED. I
okay?
know that.
Great.
Yeah.
Yeah. So again, excellent question. What we've done at Siemon, so we spend about half our time talking to customers and partners through webinars or directly helping them understand how to build and navigate intelligent buildings. The other half of what we do is building an ecosystem of partners. We have partners in our ecosystem that range from intelligent building consultants who can work with your existing design team to help make sure that they are designing as an intelligent building, master systems integrators, and even edge device partners like PoE Lighting. So we are partnered with all of the PoE lighting companies in the marketplace and have the ability to bring them into projects, make introductions, even help you purchase and deploy demo solutions in your buildings. And with that ecosystem, not only do we have the PoE lighting manufacturers that make the nodes and the software and so on, but we can also work with the local light fixture manufacturer in your country. We've
Bob,
essentially made an intelligent building in a box for you. We've put it all together in one place.
yes, true. So, Bob, the next question has three-part questions in it. How to convert a normal building into a smart building with a minimal cost? What is the time duration involved? And what is the cost savings for the client?
Great. So first, I want to make a very big difference between existing buildings and new buildings. New buildings, when we're starting with a blank piece of paper, we can design and build intelligent buildings for less money than we can traditional buildings. If you have an existing building, you can do some forms of integration, which are going to lower your cost to operate, will lower your energy, will provide better functionality, and so on. However, that is an ROI-based decision. You already have a building that is functioning. You know the cost to operate that building. And let us just say, for the sake of argument, it costs $1 million a year to operate your building. There may be a technology that is going to cost you $100,000 to install, to integrate certain systems, but it will lower your cost to operate by $20,000 a year. Well, that is a 5-year return on investment. And after the 5th year, that $20,000 a year becomes true savings. So it is an ROI-based question when we're looking at existing buildings. Probably the best example of that is PoE lighting. And I say that because if you have existing AC wiring to the light fixtures, then there is a cost associated with taking out that wire and putting in low voltage cabling to support a PoE lighting upgrade. In most cases, the return on investment is between 4 and 5 years, because the energy savings is about 40% between PoE LED lighting and AC LED lighting. So yes, it can be done. It just becomes more of a business decision than it is a technology decision. Did I get all three parts of that?
Yes. The next question is, how can we rank our products like at 6 and 7 with Chinese competitors? Bob, you want to take this one?
Is it okay to chuckle with this question with a little laugh? There is no comparison. You know, and I think this question, the answer is already known without me saying it. Siemon products are best in class. There are very few companies in the marketplace that can match the quality of a Siemon product. And you do not have to take my word for that. I highly encourage you to buy whatever country of origin you choose, whether it be China, whether it be other US companies, or anywhere else in the world. And we call them bake-offs here in the US, where you do a performance test between our connectivity and cables and any other company in the world. And if you find a company that has a better product than we do, please message me and let me know.
Okay. Do you have partners in Morocco, North Africa, West Africa?
Yes. We have
Yes,
partners
please.
all over the world. We have what we call certified installer partners that would be able to handle things like your basic LAN and your traditional cabling. We have what we refer to as certified DLP partners or digital lighting partners, and those are installer companies who specialize in digital buildings and digital lighting platforms. We have our ecosystem of partners, whether it be PoE lighting partners or consultants or master systems integrators, can work all over the world. So we have every spot in the world covered.
Yes. So one request to the audience, we have given very good application guides. These are free to download from the download handout section. You can download those guides. Those will be very useful for you. The next question, Bob, is what will be your recommendation for the integrators that do not have experience in electrical or lighting industry, and how does Siemon support the local partners?
Yeah, absolutely. So we find this problem everywhere in the world, that the local design team does not have the expertise to design an intelligent building or an intelligent lighting, PoE lighting platform. That's why we have consultants in our ecosystem that specialize in intelligent buildings. And those consultants are not going to replace the lighting designer. They're not going to replace your MEP firm. They are going to work alongside of them to make sure that the devices and the systems that they are specifying are going to comply with the intelligent building method, and the end result is going to be achieved. How Siemon can support you in that. Of course, there's the infrastructure that we will provide the infrastructure for the building. But from a pure intelligent building standpoint, and I'm going to use a very American reference here, we are the quarterback to your intelligent building team. And that refers to American football. If you're familiar with the sport, the quarterback kind of behind the scenes runs everybody. He tells them what to do. So we can quarterback that for you by making sure you have the right partners in place to perform the right jobs during the design phase and the deployment phase, so that you do get that intelligent building. And I want to mention something about the applications guides. They are, in my opinion, the best pieces of literature the Siemon company has put together for intelligent buildings, and I have not seen a better piece of literature in the market either. Not only will it tell you about the individual systems like PoE lighting, like security, like AV, but then at the end of those has a complete product list for these are the products that Siemon has optimized to support these types of intelligent building applications.
Abdul, once the PPT slide. So Abdul, you will get the recording. Also, I urge you to download the handouts which are given. Those are very informative and it will cover the presentation also. So Bob,
Absolutely.
we will take last 2-3 questions. Okay. So, Alan, what is the process required to convert a normal building to smart in the sense of software and hardware?
Say that one more time. I'm sorry.
What is the process to convert a normal building to smart building in the sense of software and hardware?
That is a difficult question to answer because it will be different with every existing building. Every existing building is slightly different, so I cannot give you an answer to cover everything. But I can tell you some general information. You want to start with an integration platform. The difference in an existing building is that integration platform will sit like an umbrella on top of all of your proprietary software. From there, there's programming logic, APIs, that are going to allow those other proprietary software to either share information or extract information from the integration platform. In some cases, you need a translation device in between the proprietary software and the integration platform. Typically, that comes in the form of what we call a JACE, J-A-C-E, and that, or a gateway, and those are translation devices. However, my caution is we lose the integrity of our data in that type of environment. And I like to use United Nations as an example. If I am there doing my presentation at the United Nations, there will be translators for people who don't speak English. The value of my data goes down as it gets translated because things I say in English do not always translate directly into other languages. It's the same thing in our building, because when you design an intelligent building from a blank paper, you start with an integration platform. So it is no longer an umbrella. You start with that, and now you design the edge devices to be able to communicate in their native language directly to that integration platform. So you do not lose integrity of data. You're able to share that and integrate those systems very cost effectively and eliminate the proprietary software that keeps you vendor locked to vendors for the life of that building. We want to eliminate that vendor locked situation. So I hope that explained a little bit, and I always go back to the partners. If you want to look at integration of an existing building, more so than anything else, you need to have one of these specialized intelligent building consultants involved with you, because they will help determine the return on your investment for doing that integration.
Yeah. Adnan, yes, thank you so much. Bahrain is actually a big market, and we are present in Bahrain market for quite some time now. And our sales representative will get in touch with you to discuss more.
Just to add, I've sent my details to Adnan, and yeah, we will connect with him directly.
Okay, yes. Thank you, Prem. 1 minute. On a particular project, who covers the cost for working with the consultants?
Great question. So whoever is responsible for paying for the design team. So I assume that's the owner, the end user, or the development team. But keep in mind, having that consultant on the team, yes, will cost you money, but they will save you many more times what that cost is. Because in traditional buildings, just networks, we have duplicate networks for many systems that we do not need. They can help streamline that infrastructure to save money. Getting rid of proprietary software will save $500,000. Using POE will save $1.5 million. It does not cost that much to engage the consultant. So they will save multiple times what it costs to have them engaged on your project.
Okay. Kasturi, you will get the recording, and I also request you to download the application guides which are given in the handout section. Bob, this is the last question that we'll take for the day. Are there any specialized equipment like NW switches whose PoE capability has been enhanced for reliability and durability? because NW switch equipment have always been data or voice specialized?
Great question. And the short answer is no. PoE is an international global standard. So if that switch is capable of delivering 30 watts, 60 watts, 100 watts, then it is acceptable to use. The PoE lighting manufacturers have lists of bona fide or tested switch manufacturers to make sure compatibility exists. I am definitely a fan of the Cisco building switches. They are not as expensive as the voice and data switches, the network switches. So they're built in a way for the intelligent building for the OT side. And they have two technologies that are built into them that I have not seen elsewhere. One is what's called perpetual PoE. Perpetual PoE. And what that means is the flow of power to the edge never stops. You can do configuration changes, firmware upgrades, soft reboots. You'll never lose power to the light fixture or other device unless you lose AC power to the switch. And if that is the case, then you probably lost power in the building, so your AC lights would be out. But that's where the second technology comes in, because that switch is going to fail over to a UPS or a fossil fuel backup or some sort of backup. So as soon as power is restored to the switch, 3 seconds is how long it takes for power to get to the edge. So you lose power in the building, the switch fails over to a UPS, 3 seconds later, the light is back on. Complies with all emergency lighting standards. But again, the other is the mean time to failure on the digital building switches is between 20 and 25 years. So you're not refreshing those switch banks like you are on your network. So I think that answered that question.
Yes.
I want to personally thank our IMEA team for all the great collaboration and support, and for bringing me in this morning to talk to all of you people. And thank you for the amazing questions. You've been a great audience, and I look forward to supporting you with your intelligent building projects.
Thank you so much, Bob, and thank you so much, attendees. If you have further queries, write to us. We'll get back to you. Thank you so much.
Great, thank you.